the operation down should any type of anomaly occur that puts the system in a potential dangerous area. The dedicated communications link is usually a handy-talkie, a walkie-talkie, UHF, and it is required that they be intrinsically safe. And what an intrinsically safe item is, say, it has special seals in it so that you're not going to get any vapors inside and run the risk of having a source of ignition, even though it's, you're talking very low powers and whatnot, but any source of ignition has to be eliminated. So the radios are made intrinsically safe. So it's not possible for any flammable vapor to get into the actual inner working of your radio. Emergency signals have to be clearly established and understood. Vessels have their emergency signals. Terminals have emergency signals. These signals should be discussed, clearly understood parties prior to any also a vessel is going to have contingency plans. You're required to have this by the International Safety Management Code. Terminals are required to have a contingency plan. So it's important that all parties know what the other party is going to do in the event of an emergency. Vessels' moorings are going to be checked prior to any transfer, and they're also going to be checked during the transfer. You just don't bring a ship in and park it and not check things as the operation continues. The ship is a dynamic platform when it's in port. Cargo operations are taking place. Vessels draft is going to be changing. The list of the vessels is going to be changing as cargo operations are conducted. So it's important that the moorings are checked to make sure that the mooring lines are kept with a proper amount of tension on them. It's also important to closely monitor the movement of any nearby passing vessel. We do have, as I said, we have these safety zones and established around the vessel during the transfer of LNG bunkers. But in most ports, the vessels are allowed to move as long as they stay outside of that safety zone. But even though they're outside the safety zone, a vessel passing you as you're berthed alongside a vessel create a surge problem. So if there's any vessel movements in the area, it's important to have one of the officers out on deck at all time to keep an eye on the movement of vessels and to be keeping an eye on the vessel's moorings once these vessels pass. Hose connections have to be checked, and the hoses have to be properly supported. And this is normally done with slings and straps and plastic chocks so that the hose is kept in place and not going to have any errant movement. Any handling of hoses has to be done by trained personnel. No crewman without proper training can work a crane on board a vessel. So even though it's taken for, you just don't take it for granted. This can be checked. All the documentation that a sailor has with him on board the vessel. So only qualified people can operate the machinery that's going to be used to transfer hoses. As we stated in an earlier section, insulating flanges are going to be used to prevent a static charge from developing as the liquid moves through the hose. Also, we're going to make sure there's an emergency release coupling or a dry brake coupling. We'll go into the emergency release couplings in a little bit more detail later on. And again, the drip trays are under any couplings and manifolds. Anywhere there's a flange connection, we're going to make sure that there's drip trays. And again, the reason for that is if you watched the video last night, you saw what happens to mild steel if it's subjected to cryogenic temperatures. It becomes very, very brittle and can very easily fracture. I have witnessed this on board one of the ships that I worked on. We had a leak on a flange at the top of a tank, and liquid came into contact with the dome cover. The ships that I worked on were the spherical type ships, and the dome had a crack in it that was approximately 7 meters in length. It's exposed to a very small amount of LNG for a very, very short period of time, but that rapid contraction of the metal created a crack in the dome cover that, again, as I said, was about 7 in length. Obviously, we had to take action. Okay. All right. I have another question from Simon, which I will divert and I will answer. And this question: are drills on LNG vessels conducted more often than they are on dry cargo vessels? Simon, I don't know the answer to that question. I know LNG ships do a lot of drills, do a lot of safety drills, and my initial reaction to this is going to be probably not, because the drills that are conducted on board vessels are a lot of the drills are done by regulation. IMO has come up with a plan of particular drills that have to be carried out by vessels on a routine basis. Some of these drills maybe have to be done once a month, once every 2 months, once every 3 months. But there's a series of drills that every vessel has to conduct, and it has to do with the various types of failures that a vessel can be confronted with. An LNG ship is basically, it's a ship, and it's subjected to the same rules when it comes to drills. Because it's an LNG cargo, we are going to be much more attuned, much more aware of the potential of fire hazard because of the nature. As far as training goes, another question has popped up, and I'm certainly going to answer questions as we go along if we can. How often do the crew handle bunkering operations need to be retrained and updated? Again, this is something that's established by regulation. We all have to take refresher courses to keep our certifications current, and it depends on the particular area. Some of these areas you have to be retrained once every 3 years, once every 2 years. I don't believe any of them are on an annual basis, but in most cases, there's going to be refresher courses that we're required to take. And I think in the 3 to 5 year range is probably the closest I'm going to suggest for retraining. Okay, so you figure in the areas of the operations, and this just isn't for LNG bunkering, but it has to do with almost all aspects that a seafarer is exposed nowadays. 40 years ago, a seafarer received his papers and he went to sea, and that was it. He never had to have any retraining and whatnot. But as we've advanced over the years, we now see that retraining is done on a relatively frequent basis. Yes. Is there any requirement for fixed gas monitoring equipment at the bunker manifold? Yes. This is established by the IGF, the International Gas Code Vessel Construction Requirement, and gas monitoring is part of that, and it is required. That's that MSC document. I don't believe it's out in hardcover yet. I'm not sure if it's been fully adopted, but that is available if you go online. You can find it online, and it gives you the construction requirements for vessels fueled by LNG. And monitoring equipment, gas detection equipment, yes, is going to be required. We're going to go along here now. Insulating flanges, we got the drip trays, okay. Once all of these inspections are conducted, the declaration of inspection will be executed by the PIC, the person in charge from the receiving vessel or from the delivery vessel, and since it's bunkers, the PIC on board the receiving vessel will usually be the chief engineer. The declaration of inspection is also, the declaration of safety is also executed above by the party. The pre-bunkering verification is the first step to assure all operations are followed as prescribed so that there's no deviations and that they're monitored at all times. Once again, this is can become a routine operation, and you really don't want to allow it to become routine. It should be approached by the parties involved. It should be approached with the attitude that this is the first time it's ever been done. So you're going to very, very closely take a look at the procedures as they're outlined and follow them step by step. And if these procedures are followed step by step, close attention paid to them, we're going to go through bunkering operations without any incident. The personnel should have a clear understanding of every step of the transfer process, knowing how to do things and why we're doing things. You just don't automatically assume something's on a checklist that, it's just done. We have to do this because it's on a checklist. No, we're doing it because there's a reason. Everything on that checklist is there for a reason. And it's important that the operating person know why they're doing it. Again, communications equipment's tested. And what we'll do now is I believe we're going to actually take a look at a declaration of inspection. Okay, all of this is fundamental, can often be taken for granted, but we always have to follow the saying. We're going to trust you, but we're also going to verify everything step by step. Okay, that takes care of that section. Move on to the next one, which is actually, I believe, is the declaration of inspection. Okay, do we have any questions or thoughts on this particular portion of the course? All right, let me pull up our next PPT. Yes, Simon, I believe you'll be able to get the PowerPoints did yesterday. You can check with Jared on that. Okay, as I said before we started this morning, there's a lot of overlapping material in these sections, and so what we're going to look at now is the pre-bunkering meeting. Everything that we just talked about in this in section 3.7, we're going to now actually sit down face to face and conduct this pre-bunkering meeting. It's formally done. It's not it's not done for showtime. It's done because this is an important part of the process. So we're going to take a look at that pre-transfer checklist items and discussion items, and among some of the things that we talked about earlier, we're also going to take a look at the current and future weather conditions. We know what the weather is when the ship comes alongside, but we also want to know what's going to happen over the next several hours. You don't want to get caught in a sudden storm. Let's just say there's a series of say violent thunderstorms that are going to be moving through an area, uh, uh, such as overseas. In Indonesia, we used to have what were called sumateras. It was a very strong wind that would suddenly come up without warning. So you wanted to be aware of what the weather is going to be. Again, we're going to make sure the receiving ship is safely berthed. We're going to make sure that the delivery ship, if it's a barge or a small LNG ship, is also safely berthed. The mooring plan is something that's exchanged between the receiver and the deliverer prior to any operation, so that everybody knows where mooring lines are going to be placed. Both parties can take a look at the plan to make sure that the vessels are going to be safely secured to each other. Again, the fenders are properly positioned and properly secured, and again, the communications language has been agreed upon. Radars are to be powered off, and the vessels are alongside of each other, and operations are going to be conducted. Oftentimes, this is a port requirement in LNG terminals. Radars have to be secured during cargo operations. I would imagine also at LNG bunkering facilities, this is standard operating procedure. But also, if you're not in a bunkering facility and you're just in a regular port where you're having a bunker operation take place, radars should be secured. Very remote that a radar could create a problem, but again, we don't take any chances when we're dealing with LNG. The vessel's VHF radio is set to a low power setting. Most of your VHFs can transmit at 25 watts and at 1 watt. Vessels in port alongside, it has to be set to low power. Again, just on the off chance that something could happen, don't want to have any errant power source that could possibly create a problem. Smoking regulations, naked light. This is one that if you're not familiar with the maritime industry, you say, my goodness, what is a naked light? It's just simply an unprotected light bulb. All of your lights on board vessels usually have some type of globe arrangement around them to protect them. In the gas envelope or gas sensitive areas, you're going to have gas tight fixtures. So you want to make sure that there's everything is in the proper equipment is being used, the proper lighting equipment is being used, and galley requirements are being observed. That's one that's kind of a carryover from the days of yore when we had oil-fired stoves in the galley and whatnot. But it's a carryover, and maybe it's tradition, but it's still kept into vernacular. It's still kept in the document. And that the ship's main radios are grounded, earthed. In other words, you have to ground the transmitters so that there's no errant signal. We're going to agree upon emergency signals and shutdown procedures. Firefighting equipment, again, tested and ready for use, and that's all parties involved. And that the navigational bunker signals, which are required by international regulations, are properly displayed. And again, an overlap, the bunkering hoses are inspected and tested. If there's any bunker manifold that's not being used, we have to be certain that there's a blind flange installed on that manifold. Blind flange is a full face flange, full face cover, no openings or holes in it, and that has to be properly secured to any manifolds that are not in use. The alignment of the valves in your bunkering system have to be correctly positioned and checked prior to the transfer and during the transfer. Once gauging is completed, the quantity to be transferred is agreed upon. And during this process also, we're going to agree upon what the maximum pumping rate is going to be. If for the bunkering operation, we're talking, we're not talking huge quantities of LNG to be transferred. One of the examples yesterday was the ferry boat where the capacity of the tank was 65 cubic meters. So the maximum pump rate in a bunker transfer situation like that, it's going to be relatively low. I'm not quite sure what the pumping rate of a tanker truck transfer is, but just say for the sake of argument, if the bunkers is coming from a tank truck, the PIC for the tanker says, okay, we have the capacity to transfer 15 cubic meters an hour. The receiving ship will say, okay, that's no problem. We can receive 15 an hour, and that's agreed upon, and that's what you do. When we're talking large LNG carriers, we're looking at transfer rates of upwards 12,000. So obviously, when you get into larger vessels, transfer rates increase exponentially, much higher. Your typical bunkering operation probably will not take more than a couple of hours. That ball capacity, and you get up to the larger capacity vessel, have a capacity of 1,000 an hour. We may be looking at 2 or 3 hours, right? 2 or 3 hours for transfer time. A topping off rate, that what happens is as you approach your tanks being filled, you reduce the transfer rate. You don't want to be pumping at maximum rate as you're coming up to the highest level inside of the tank. You're going to have there's a lot of turbulence and movements of the liquid within the tank, and you don't want to run the risk of having an emergency shutdown because liquid has splashed up, say, to a high-level sensor or something like that. So as you approach the full level of the tank, you reduce the transfer rate and you bring that level up to full capacity point at a very, very slow rate. And that rate you're going to agree with your deliverer prior to actual transfer. The bunker station is always going to be manned by trained personnel. You're not going to leave the second cook in charge of bunker. Anyone who is not that I'm picking on cooks, not just that the people who are involved in the bunkering operation have to be fully trained. They have to have a knowledge of liquefied natural gas, its properties, characteristics, and everything that you are being exposed to in this course. Personnel have to have a knowledge of the location of the emergency stops and how to properly use them. Again, we're going to look at drip trays, position below liquid manifolds and connections, and a vapor return connection is going to be made. This is not necessarily true in all cases. It's going to depend upon the delivery modality and the type of a tank that you have on board your receiving vessel. So in some cases, you will have vapor return. Other cases, there won't be vapor return. And this is something that will be determined again by the type of vessel. If by any chance your marine gas oil or marine diesel oil is also going to be transferred, you can have what are called SIMOPS, simultaneous operations, SimOps includes cargo operations while LNG bunkers are being transferred, and it also can involve the transfer of other type fuels. As I said, all of these diesel motor engines in vessels nowadays have the ability to dual fire. Some of them are tri-fired. You can fire 3 different types of fuels. So in some cases, you will be also transferring your marine diesel oil, your low sulfur diesel, or perhaps a higher sulfur content fuel for use when the vessels are outside of your emission control areas. So you can have these operations taking place simultaneously. If you're transferring the marine gas oil, marine diesel oil, it's important that the deck scuppers are plugged. Your deck scuppers, again, for non-marine people, these are the deck drains. It's a drain hole that's located in various areas throughout the deck. And when you're transferring an oil product, you have to have these things plugged so that if there is a spill, you don't get any oil into the water, because these drains, they drain directly over to the side of they go down in an internal tank, and eventually they go over the side of the ship directly into the sea. Your sea and overboard discharge valves have to be closed, lashed, tested, and checked, made sure that they are lashed. Any of these overboards that's not in use. Your cargo bunker tank lids have to be closed, and ullage ports protected by proper flames. An ullage port is an opening through the deck into a tank, and if they are in use, they have to have flame screens on them. Flame screen is a device. Again, it's a screen, and what it prevents is any flash of a flame into the tank, into the vapors of the tank. Again, the recording of temperatures and pressures, quantity transferred to be agreed upon, and the starting rate is also maximum transfer rate is agreed upon, topping off rate, and maximum pressure at the manifold is agreed. All of these items are of critical importance, have to be agreed upon by both parties. Just don't willy-nilly start an operation and see, well, let's see where we're going to wind up with pressure at the manifold. No, we have to know what it's going to be beforehand, and then it has to be monitored during the operation to make sure that what we said we are going to do. The pre-bunkering meeting process is critical to assure that nothing can or will go wrong. And believe me, as best you try, sometimes things do go wrong, even though you agree. So this isn't a guarantee, but it does prevent most cases of disagreement or issue. Some of the items to be discussed are obvious, but the key is that all parties at the pre-bunkering meeting clearly understand the process. If there's any doubt or uncertainty, ask questions. Again, we're going to trust, but we're going to verify at all stages of the operation. Okay. If there's any questions on this section, please let me know. Nine. All right. All right, the next area that we're going to take a look at. Okay. Some big differences in discussion about the LNG. Okay, excellent question, and you're absolutely right, Simon. Simon has asked me, during bunkering, heavy fuel oil, often big differences are discovered, and there often is a discussion about the amount of cargo. What about LNG? Outstanding question. I appreciate that one. Bunkering operations are notorious, absolutely notorious for differences, and that's why we mentioned, we were talking yesterday about this custody transfer system, gauging system on board the LNG carrier, and also the gauging of the delivery vessel. In most cases, as we've stated yesterday, and I believe this will hold true with the LNG bunkering operation, the figures used by the receiving vessel, by the receiving vessel, will be agreed upon as the figures of the actual transfer. So you don't wind up with these disputes in the quantities. When you're dealing with bunkers, historically, the chief engineer will do his gauging, and he says, well, we received 2,000 metric tons, and the people on the bunker barge say, no, well, we delivered 2,500, and you have this dispute. We don't have these disputes with in the LNG trade, because it's agreed upon beforehand whose figures we're going to use, and in most cases, it's probably going to be the receiving vessel. They have a certified gauging system that's been certified by local customs, and this value is considered to be the accurate value. So that is agreed upon. Okay. Okay, we're going to take a look at some rules and regulations. Where do the rules and regulations come from? Well, in the LNG trade, they come from so very, very many sources. Another question has just popped up. How does one ascertain the quality of the LNG? Or what was ordered, and how is sampling done? Okay. When you're using an LNG bunker, you're talking essentially probably a generic cargo, if you will. All right, and the composition of every LNG cargo different. So you're not going to see yourself in a position where you're ordering an LNG cargo that is 89% methane, 4% butane, 3% pentane, everything. What you get, and the interesting thing about LNG, as we discussed yesterday, it's a cargo that's constantly changing. The cargo that I load in Nigeria, for instance, when that cargo gets to Korea 30 days later, is going to be a different cargo, because the cargo changes. Methane is boiling off, so the methane quantity is going to drop a little bit. The heavy ends are going to be a little bit more dominant. So when the cargo is placed on board the ship, when it's delivered on board the delivery vessel, a sample is taken, and in the bunkering operation, I can't say that this is exactly how it's going to be done, but I am going to be, I'm pretty certain in saying that there will be a cargo sample taken prior to when the delivery modality is loaded. And that sample is taken to a laboratory and it's analyzed. So the delivery vessel is going to come alongside, and they're going to have a piece of paper and say, okay, this is the cargo that we received. This is the LNG that we received. This is the composition. All right. As far as sampling goes, as a receiving vessel, to the best of my knowledge, there is equipment out there that you could sample it and determine exactly what you're getting, but essentially it doesn't really make any difference. The quality of the cargo essentially is it's pretty stable. It's pretty much the same. I mean, it's the difference between 89% methane, 92% methane, it's really not that great. So it's not it doesn't seem to be as critical as it would be when you're talking your heavy fuel oils, because when you're talking your heavy fuel oils, you can have water in heavy fuel oil, you can have high concentrations of sulfur in it and whatnot. So the sampling is much more critical when you're talking about your heavy fuels and your intermediate fuels. With LNG, it's as I said, it's a pretty generic cargo. So I don't know if that really answers the question or not. Again, you can sample, but to what end, I'm not quite certain that would be. You're getting LNG, and you're getting a cargo that has a certain BTU value going to fire in your engine, and that's the important thing. You're not worried about impurities. You're not concerned about sulfur dioxide. You're not concerned about any of this stuff as you would be with your heavy and your intermediate fuel. So I hope that answers your question, Kelvin. Rules and regulations, flag states. You have various registries throughout the world, and these are what are called your flag states. You have Marshall Islands Registry, you have your Panamanian Registry, you have U.S. Registry. Any country that registers vessels, flag state, and all of these flag states are signatories to international agreements and under the IMO. This is one of the better things that have happened in the maritime industry over the years. The evening of the field, the evening of requirements, so that you're getting a higher standard throughout the world when it comes to shipping operations. And it's the responsibility of the flag states to make sure the vessels that are flying the flag of that country are adhering to the international rules and regulations established by IMO. There are other rulemaking organizations. You have your classification societies, which are primarily involved with the insurance side, your liability insurances and whatnot. For your vessels, you have the American Bureau of Shipping, that's ABS. Have DNV, German Lloyd's Register. You got these various classification societies, and they also have requirements that vessel operators have to adhere to. So specific codes that are out there that have to be adhered to as well. You also have the International Gas Code. The International Gas Code has to do with the construction of vessels that are going to carry LNG. And you now have the International Fuel Gas Code, which has to do with the vessels that are going to be fueled by LNG. These are some graphics of LNG carriers. Different types and different sizes. You have your vessels with your prismatic tanks. That's the Technagas gas transport Technagas. And you have your vessels with the spherical tanks, perfect spheres. You also have your the vessel. There was that Type A tank, the one that had an awful lot of steel in it, whatnot. Self-supporting tanks, and then you have again Kverner, Moss, and gas transport systems. Technagas and gas transport, as I said earlier yesterday, these are two companies that have since merged, so they now are a single manufacturer, and approximately 60% of the LNG carriers today are of that type system. The ships with the spheres, the Moss system. The Japanese have done, they are great levers in the Moss system, and they have made some modifications in these tanks now, where the latest version of a Moss tank is no longer a perfect sphere. It's an apple-shaped tank, so that the capacities can be increased without necessarily increasing the breadth and length of the vessels. So they've made advances to increase capacities, and you now have some tanks that really don't look like perfect spheres. Okay, another question here. Simon is asking about certificates required by LNG vessels, difference in dry cargo vessels. Okay, you have your gas fitness certificate. This is the primary difference as the type of cargo that you're carrying. So your fitness certificate is probably the biggest difference. Okay. That's the in contrast. Okay. Most of your certificates, you're going to have the identical type certificate. Because of the nature of the cargo, you have your gas fitness certifications, and that's the primary difference. All right. Flag state maintains a register. We're going to go through this fairly quickly because it's basically just for information purposes. They assume jurisdiction under international law. National and international laws ensure the safety of the vessel. Vessel surveys are conducted and ensure qualifications. This is the responsibility of the flag. Hopefully, under IMO, the playing field has been evened out greatly over the last 30 years. So you don't have these vast differences that we had years ago between registries. Ship operators, some of them maybe not as scrupulous as others, would all go to a flag state that maybe wasn't as attentive to safety regulations and whatnot. With the introduction primarily of the safety management code and with the responsibility of the maintenance and operation of ships is shared by the management people, we have seen a lot of these differences have been greatly reduced. Most of your flag states are very, very well respected in a society. This perhaps wasn't as much the case 30 years ago. These are some examples of the size of the various registries throughout the world. As you can see, the Panamanian registry is probably still the largest in the world with the number of vessels and the percentage of the worldwide tonnage, followed by Liberia, Marshall Islands, Hong Kong, and Singapore. And as you can see, China is now moving up in those ranks. Okay, so all of these are, they're all valid registries, and you're going to see these flags throughout the world as you travel. Various rulemaking bodies, as the IMO, the International Maritime Organization, and under their auspices, the International Gas Code. And the International Gas Code would be responsible for the bunker barges and bunker ships. The IMO also has the International Gas Code for ships fueled by LNG, and that's going to have the rules and regulations for the construction of the receiving ship only. The vessel that's going to be burning LNG as a fuel, those rules will be established by the IGF. Again, it's for construction only, not for the actual, the actual operation is another issue. You have the society, the SIGITO and OCIMF. These are two private organizations. They they don't have rule-making authority, but what they do is they have established guidelines for port operations and the transfer of LNG. And even though they don't have a binding authority, these guidelines are very, very much adopted throughout the industry and are pretty much considered the Bible for port operations and the transfer of LNG. That's sigto.org. If anyone wants to check, they have a lot of free publications that are definitely worth reading. A lot of their free publications cover some of the material that we've covered in the course, and if you have a further desire to learn about some of the stuff, you can download an awful lot of their publications at no cost. We also have various port regulations, as we mentioned yesterday. We have Antwerp, Rotterdam, Singapore. All of these ports are going to have their own rules and regulations, and in most cases, those regulations are consistent with international rules because they do have the authority. They can establish that might be unique to these ports. So it's important that the ship operators and the ship staff have copies of the various rules, these ports that they're going to be visiting. This way, you're not caught short. Then you have various onshore regulatory bodies, rules established by the EU, by the National Fire Code here in the United States, rules established by FERC, which is the Federal Energy Regulatory Commission. All of these agencies issue regulations on a regular basis. They're in most cases are published in advance notice given to people to stay on top of. But like all regulatory agencies, rules are promulgated and changed. So as you can see, there's a myriad of groups that establish rules for the transfer of LNG, for the control of LNG operations. According to the IMO, the International Maritime Organization's flag states must enforce all applicable international laws, participate in all work of all international organizations, disseminate pertinent information. Okay, we're still in this transition period of I believe as oil to gas. It's inevitable that over the next 20 years, 10 to 20 years, we're going to see this conversion in most cases where gas is going to become, natural gas is going to become the primary source of fuel. It makes absolute sense. It's the easiest way to adhere to the control of emissions into the environment, and it's also economically beneficial and economically feasible. So we're going to see more and more new construction, dual-fired engines, gas-fired engines, and we're going to see more and more conversions of existing tonnage over to the capability of using gas as fuel. But we still have the chicken and egg syndrome going on. Unfortunately, here in the United States, we're still in the position of they say, well, we don't want to make an investment in LNG because there's not that many users out there right now. And of course, the users they don't want to convert over to LNG because is the fuel going to be available in the various ports? So we have this period of indecision. Who's going to make the first move? Who's going to make the capital expenditure? Who's going to jump into this thing first? Get the ball rolling. Europe is way ahead of the U.S. in area. But I'm confident the U.S. is going to be following very, very quickly, and we'll be catching up as we go along. And we have to deal with this. Gee whiz, I want to convert to LNG. I'm not going to be there and happen. With the development of a consistent international framework, entities can make investment decisions. Again, am I going to have a market? Am I going to invest billions and billions of euros, billions and billions of dollars into a infrastructure, and then nobody's going to use it? It will happen. Investors are going to be attracted to this as we go along. Once they see that there's the opportunity to make some money, they will jump in this, and we're going to see it grow. The IGF code is the International Code of Safety for Ships Using Gases and Other Low Flash Point. And it covers the design standards for gas ships. It was adopted by the IMO document, which is entered into force January 27. It does not cover crew training requirements or bunkering interface, and it does not address port-specific operational procedures. Again, it's for the construction of vessels that are going to be using gas. Let's see. The regulation V/3, the International Convention of Standards of Training and Certification for Watchkeeping, that's referred to STCW Convention 1973, 1978. This covers the training. STCW requirements cover just about all aspects of training for merchant mariners on an international basis. And they've established the training requirements. They've established retraining requirements. Sailors today spend a great deal of their off time when they're on vacation being retrained, being upgraded in their capabilities. So it's unlike it was, again, when I entered this industry many, many years ago, when an officer left the ship for vacation. He was on vacation. He didn't have to do anything. He just waited until his vacation was over and then went back to work. Nowadays, when an officer goes on vacation, chances are he's going to be spending several weeks of his vacation going to school, either being trained or retrained to meet STCW requirements. Training requirements are ongoing. Training requirements are always increasing. They're never going to be less. They're always going to increase. So the STCW covers training requirements for officers and crew on gas fuel ships. They cover training and requirements for all ships, not just gas. Adopted at the IMO and enter into force again in 2017. But they do not have training requirements for shore-based personnel. Shore-based personnel. I don't know what their requirements are. Most of your shore-based personnel are former sailors, so people actually involved in the operating department are usually chief engineers, have come ashore to work for a while, maybe have decided to go, and they continue. They want to retain their documentation. If a ship's captain decides he wants to go ashore and work ashore, or a chief engineer, they can go ashore. If they want to maintain their certification with an active mariner's document, they have to maintain their STCW training requirements. Would have to go for refresher, whatnot. If they decide they want to put their documentation in abeyance, they don't have to go, and they would decide, okay, well, I'm not going to go for these retraining courses. And their document is put into a state of not suspension, but a state of suspended animation, if you will. If they ever wanted to return to sea, they would have to go and take all sorts of refresher courses. So your shoreside personnel are usually very well trained, very, very, very capable people, and the amount of retraining that they do is basically going to depend upon whether they want to retain their active mariner certification. Oftentimes, so these people, if some new standard comes along or new requirement comes along, they will go and take the training with the seagoing person. It's not that they just go ashore and decide, well, I don't have to learn anything. They're often subjected to training. And the ISO is a standards establishing entity, and they have a committee on ship design, liquid and gas fueled vessel working group. They have an LNG bunker standard. It excludes requirements for port-specific risk assessment and establishing bunkering. Again, what happens within the ports is usually going to be established by the ports. Ports are going to come up with their own particular standards that have to meet their own particular requirements. So even though we have international standards, we're going to have a standardization of all the rules and regulations as we go along in this evolutionary process. We will see varying rules and regulations from port to port. Port authority does have the authority to establish their own rules and regulations. The fuel code is based on the gas code, and the gas code has been successfully applied for the design of gas carriers for years. We have a standard arrangement for gas carriers with gas storage forwarded, the accommodations, and gas piping on deck. Every aspect of the construction of a gas carrier is covered by the gas code. This code is well established and worked well for over, as it says, 40 years. The routing of fuel piping, the gas code limits cargo gas used as fuel to piping in the machinery spaces. And the gas code allows for the runs of gas fuel piping in other areas of the ship, provided they are protected by double wall pipe ventilated ducting. Anywhere you have gas passing through a space, it either has to be a double wall pipe or the space, or you have to have excellent ventilation. The requirements will be established for a space, how many air changes have to take place in a minute, and that space has to have fans that do provide the capacity. So you're not going to find yourself in a situation where you can have a buildup of explosive vapor should there be a leak. And gas code allows for the installation of gas handling rooms within the hull. That would be your bunkering station. It's going to be a space actually within the hull. Fuel tank locations established, and due to its lower energy density, LNG and its associated containment system can require up to 3 times the volume of the equivalent of heavy fuel. Your heavy fuel oil, on your traditional ship, you have tanks dedicated to fuel oil, and you fill the tank with fuel. So you utilize all the space within a tank. When you're dealing with LNG for fuel on board your ships, as we saw yesterday, we have the various type systems. We have the set system. We have the isotainer systems. If you have a tank, that tank takes up a large amount of space, and a lot of that's for fuel. So as a consequence, you can require up to 3 times the volume of space to get the equivalent amount of the ship. This is an economic trade-off. It's been studied, and it's still economically feasible, even though you're losing this space. Any space on board a ship has value. If you can put cargo into it, it has value. So if you're using space for nothing than just the area around a Type C fuel tank, this space isn't earning any money. But even though it's not earning any money, it's still cost effective to make these conversions over to LNG as a fuel. Okay, so we see a decrease in revenue volume of the ship, particularly for transoceanic. Again, it's been well thought out, well laid out. See this trend now going to LNG as fuel on large container ships. So it's worthwhile. There's no question about it. The gas code, let's see, we're going to compare the gas code for fuel, gas code for vessels. ESD protected engine room. The gas code requires that all gas-fueled pipe in the machinery space be protected by double-walled ventilated piping. Okay. Again, you have to have, just can't run a pipe into the engine space of the vessel. It has to be double-walled. It has to be ventilated. You have to have the ability to have gas detection in this double-walled system, so that should there be a failure, you're going to generate an alarm. You'll generate a shutdown, so that you keep your vessel in a safe position. The installation of this system, for some reason, is difficult with small engines, and that I'm not quite sure why this is an issue. I haven't been involved in the actual conversion of vessels to dual-fired fuel. But anyway, the International Gas Code for Fuel permits the elimination of the double-wall protection if the ignition sources are limited and electrical power secured in the event of a gas is detected in the machinery space. This could very well be because of the short distances involved, oftentimes, in the way the gas source and where the gas source is located with respect to the engine. I suspect that the way this is established, it's a very, very safe. It's still a very, very safe system. I'm not particularly crazy about it. I'm certainly in favor of double walling anytime that you have gas going into a machinery area or going through an internal space of the vessel. This is something obviously that's going to be closely watched as we go along, and hopefully the idea of the limiting of electrical power, securing it in the event of a gas leak. This is something that I'm not quite sure about. Operational methane venting. Methane is a greenhouse gas and has a potential of 30 times of that CO2. So we're not going to be dumping methane into the environment. So we're going to have to minimize methane as a methane release as part of the bunkering process, and we saw how that is accomplished yesterday with the dry brake couplings, where the amount of LNG minimized, and it can be eliminated. It can be eliminated totally by taking some extra steps. We're going to go through that in the actual transfer process when we talk about the transfer process of LNG, because all of these hoses, even though we're using these dry brake couplings, we can add an additional step into the operation where the hose is actually inerted with nitrogen, so that when that dry brake coupling is released, you're not releasing any methane into the environment. Again, the gas code requires the dry brake couplings to reduce the requirement for venting during the disconnect. Crew training requirements, again, we'll return to that, for gas-fueled ships are based upon regulations contained in the STCW regulations. Key performance indicators, KPIs, have been edited to delete topics required for the carriage of gas cargo. I'm going to pass on this slide because I'm not okay. I'll be honest. I'm not even sure how that got in there. I'm sorry about that. It's anticipated that the crews of LNG bunkering vessels will comply with the training requirements for gas carriers. This is important. This is part of what you're doing for those folks who may be involved in bunkering operations in the future. The LNG fundamentals course it is a course that, I know in the U.S. and in most places, it's just a minimum 2-week course, and that's just to deal with LNG and the science of LNG and the physics of LNG and the carriage of LNG on LNG vessels, and that's a 2-week course in and of itself. So we're trying to cram an awful lot of information here into a very, very short period of time. But the people involved in the bunkering operations are going to have a fairly good working knowledge of LNG and the training requirements for the people on vessels, fueled vessels. It's going to very, very much parallel that for people on gas carriers. If you have a copy, or if you can get a copy of the uh, DNV regulations, Detnesky Veritas Class Society, they break down the training requirements that they want to see implemented for vessels that they class, and they break them down into three sections for the going from the people who are least likely to be involved in the bunkering operation up through the people who are directly involved. And those regulations, there's certain requirements for each level. So when you get up to the level of people who are responsible, those requirements very, very much mirror the requirements for people who are working on LNG carriers. And that's one of the reasons why in this particular presentation, I'm concentrating a good deal on what happens on board LNG carriers, because ultimately the regulations for gas-fueled ships are going to pretty much mirror what we see. Okay, in the LNG cargo transfer, the ship-shore interface is determined by best industry practice established by the major LNG terminal operator. This is basically, this was established by SIGTO over a period of years, and best industry practices basically have been adapted and integrated into international regulation. Many of the regulations that we see on an international platform have been basically established by best industry practice. Seen that these practices do work and that they do provide a high degree of safety, so they were codified and became regulation. Due to the regional nature of the LNG bunkering, there's a need for a global standard to ensure compatibility with connection procedures. And this is the evolving part of this operation. The presentation that we've put together here, you may get the impression, well, it jumps around from one thing to another. Well, this is different, but how come this is different? Why is this? Because we haven't come up with we haven't come up with standards. And that's something that I'm certain the IMO is going to be working as we proceed in this version of conversion from oil to gas. We will see a narrowing of the different standards as we go along. So the LNG rules and regulations stem from additional national and international jurisdictions. Flag states have considerable influence on their own maritime areas, and at the same time, the IMO and its existing and emerging codes have global influence. LNG vessel operators need to know which is which and when. Okay? Again, we are going to come to a meeting of the minds over the next several years. It's going to take a degree of patience and tolerance as we go along. Until these variations that we're running now are totally eliminated. There will be a standard. Eventually, there will be an international, worldwide standard. So that if you go to Houston, you're pretty much going to be doing the same thing that you're doing in Singapore, maybe with the exception of some local port regulations that might be a little bit different. But it's going to take time. And it's going to take a lot of patience on the part of the parties who are involved in this. So in any event, I do believe that concludes this section. Yes, it does. And now that I probably have you terribly confused, are there any questions that we have this morning? What do you think we got? Excellent question, Kelvin. This is an issue that my understanding he has. Methane has 30 times the greenhouse value of CO2. So he asks, what do I think of or say regarding the dangers of gas flaring, as often the case in crude oil production locations? Nigeria, he's using as an example. Uh, unfortunately, unfortunately, this is a reality of life. Uh, it's going to be totally dependent upon each individual country how they're going to deal with greenhouse. Some countries obviously have been very, very aggressive, and as a consequence, major oil companies have had to reduce flaring. In many, many cases, have not only reduced it, but have virtually eliminated it. Depending upon where we go in the world, you're going to see these various differences in flaring. Obviously, there's an economic value to everything that gets flared. And I think as countries see this, and as the oil companies see this, they will make continued efforts to recover as much as possible, minimize flaring. It's unfortunate that some countries are in a position where they have to, perhaps they feel that they have to allow the emission standards not to be as stringent as they should be to keep these operations within the boundaries of their country. There's just so many different things that enter into it. You know, if nothing else, I think economics will prevail ultimately in this. Somebody's going to say, gee whiz, regardless of what it is that we're flaring, if it has economic value, somebody's going to figure out how to recover it so that they can make a dollar, make a euro on it. This is the thing that motivates almost everybody. So if they're not doing it for the altruistic value of saving the environment, they'll do it to put a dollar in their pocket. Hopefully this will be a motivator for many of them, and we'll see a reduction in flaring. There has been a great deal in reduction in flaring throughout the world along. It's obvious. Okay, Jared, thank you very much. We'll see you back again about 11:10, and we'll continue trudging through this sometimes not so exciting material, but hopefully we move forward. So I'll see you at 11:10. Thank you.